So to go to main, very important things. For that one, again, we what we say, the time is not enough. If I go faster, some may not get it also. Okay, so I don't know your exact background qualifications also. How many are from engineering? How many are from CSE, IT? How many are from non-engineering background, non-computers background, networking background? I don't know. So right. So we'll go slowly. So we'll learn better. Okay. First one is interconnection of two or more devices is called a network. Very simple, guys. Okay, it is. Here is a one device. It's a device. Why the people use a device, not a computer? Okay. So because of computer is a device, laptop is a device, mobile phone is a device, your printer is a device. Okay. LED, smart LED is a device. Your router is a device. A TV is a device, right? Google Home or Echo Dot. These are all devices only, right? So these devices want to connect. Okay, so raise they are connected. Okay, not to want to connect, they are connected each other. They are connected either directly or indirectly. They are connected. That is called a network. Connected. Just you have two computers. You took a cable. You connected back to back, or maybe you connected through switch, or you connected through router. How you connected is a different point, but you connected. So that is called a simple network. Okay, next. If you want to make a communication between these interconnected devices, if you want to make it, if you are make a communication between these devices, connection is okay, but once it is connected, what is the purpose of network? To communicate from one device to another device, right? So obviously, if you are connected to communicate, we need to connect first. So that is called a network. So once network is created, then we should communicate from one device to another device. So that is called a networking. That is called a networking. So what is the use of this networking? What is the use of this networking? So if you go to the stories, then it is like this. I have a laptop. Lot of data is there. Someone in my office required some data, some information, or some these PPTs. For example, Sai sir required this PPT, or maybe Madhu sir required this PPT, or maybe Sudeshna madam want to share some information. Okay, so what happened? You need a connectivity, either physically connected or logically connected. So normally, when I was in a diploma, that time computers are there, guarantee. Internet is also there, but very less places only internet connection. Like cities like Hyderabad, internet connection is there. Okay, cities like Hyderabad kind of stuff, internet connections are there. No problem. Little bit, no problem. But if I go to Visakhapatnam, then we have to go to Visakhapatnam cities, not beside a villages. I stay in a village, so village means it's a town. Internet is very difficult to find. Okay, and if it is internet is also very costly, very slow also. Okay, same speed Hyderabad 5 rupees. Here it is 30-60 rupees like that. Okay, so people the demand is there. People don't change, so they will charge more. Okay, so that time that it is a different. I am telling a 20 years back story, not 2 years back story. Okay, so 20 years back story. That time internet is new. So what I have to do? So very simple. I created my project. I'm documenting my project. So then I took two floppy disks, one for backup purpose. Okay, so I take a floppy and I have to go to internet center. Then I document the thing because I don't have a computer in my hand. So I document each one and adding the photos and all these things. And I have to store in a floppy disk. Floppy disk size is 1.44 MB. So I have to compress the data, or I compress the floppy disk kind of stuff. It is happened. So that is not open in other places because I compressed in 98. So XP or a lower version not understanding that kind of stuff. Okay, that is Windows 98 compression. Forget about it. Guys, what happened? So email communication is also there, but we are not much aware of email because if you find a computer, may not be internet connection, may not be internet connection. First of all, that is the first thing. You may have a internet or you may not have a internet connection. So that is the first thing. And second, I think that time we have a computer in home. My sister computer is there, but no internet connection. Internet is we disconnected finally. We have that's very costly internet, very slow also. That time is a diploma time, 2003. So we have a computer in our home. So I documented in my home, but to take a printouts, so I have to go to internet center then generally. So that's where the Xerox shops and the computers are there. Okay. So final edits also there, right? So I have to store in a floppy disk. So I have to go with the floppy disk only. So when I was in Visakhapatnam, so in my home I have a computer. So I did it, completed everything. So I have a little computer knowledge in that time. So I done my project documentation myself. So then my college in Hyderabad. So I have to go to Hyderabad. I carry my floppy disk. So because I have to take a printouts in my town, it is not that computer come printer kind of stuff. Facilities are very less. That too, it's a project, big book. Okay, not 1-2 pages. So we went there. We finalize. We take the friend's reference copy. Front page editing is important. Some names are important in that one, titles are important, so we don't know that point, so we'll take it from the friends or a college previous senior batch people project. I edited there and then finally took a print and submitted. Okay, so what I have done, I created a document, I carried in my floppy disk, and when I go to Hyderabad again, I use it. Finally, I take a printout. That's it. In my engineering, so that's a different point. In engineering, so we transfer the data into the CD because floppy is very less that time. Okay, so we put it in a CD. Okay, CDs are very challenging because difficult. That time no internet connection also. In 2005 itself, very less places in that is also a village. I was in a village when I'm studying in engineering. So that time computer is laptop is there, but still we don't have any internet connection in the room. Okay, we know the internet better that time. Okay. So nowadays, what is there? If I have a document, I want to share it. How I'm sharing it? Simply put it in a Google Drive, like a Sai sir, Ravan sir and Sudeshna madam sharing the data. So how they sharing? Recording with the Google Drive. So any person from anywhere, you can able to download the data and you can access it. I'm putting data into YouTube, so anytime any person, okay, not with the link or without link, you can able to access the video, right? So this is what the development from last 20 years. You can share the data through WhatsApp, right? So morning schedule is changed little. Sir want to interact with you. So luckily I have a little delay in morning. So then sir is taking a class, right? So how we communicate? So either phone or WhatsApp, links are sharing through WhatsApp, right? Documents we are sharing through WhatsApp. Okay. So earlier days I have to carry in my floppy disk or a CD-ROM or a next pen drives. Now it is not required. So simply put it in a OneDrive or put it in a Google Drive or share through WhatsApp, share through different things, right? So we can able to sharing things, okay, through share through emails. Documents we can share through emails, right? So we can send a message. So this is the evolution of network. So earlier days, so its problem is transferring a data or communicating from one device to another device for a sending information or a communicating means sending information or receiving information become very difficult. So then this network is created and it is very helpful for any organization. So later on days it is evolved in the very big large size. Okay, so that's the point I told the story. So again, what is a network? Interconnection of two or more devices called a network. Communication between two or more interconnected devices called a networking. Communication is there, networking. Connection is there, network. Internetwork is a connection of two or more networks. I created a network. There is a network is there, like I have 10 computers. Then I created a network. In another room, I have another 10, 15 computers are there. I connected them. So there is another network. Now I want to make a communication between two networks, either physical networks or logical way. So that is called a internetwork. Okay, I connected two or more networks called a internetwork. Internetworking, communication between two or more devices. Communication between two or more devices. Okay, called a internetworking. Sorry. Communication between different networks. So I said one room I have a 10 computers. There is a network. So it is one single network. I have another network in another room or in another building. I have another network. So then what happened? I connected these networks called a internetwork, and I make a communication between those networks is called a internetworking. Yes, there is a different type of networks are there based on geographical range or a size. Okay, so it is like a LAN, CAN, MAN, WAN. Four type of networks are there. Local area network, campus area network, metropolitan area network, wide area network. Yes, are you getting the point?
Yes, sir.
Okay, so in addition, so some people are asking me like, sir, what is span is there? You're not teaching, you don't know anything kind of stuff. So I added these kind of stuff also. There is a, but in exactly like as a Cisco textbook. So only 4 networks are there because I know the networking concepts in my engineering, first of all, okay. And second one is I have taken a course called CCNA, routers and switches, and I am the trainer for a very long period of time for Cisco networks. I'm very good at while teaching. I don't just watch a video and teach it or take a PPTs and teaching it. I don't do it. I study from the textbooks. That time we don't have much internet materials also, so we study from the textbooks. I never seen a pan hand kind of stuff. Okay, so nowadays people are adding this kind of stuff, but still it's a valid point because what if someone is asking a question, what is pan or what is hand or something, so other than these things, so you can able to tell some answers. Okay, so LAN, local area network, it is like if you take a building, either LAN is a very small space, like I have a 4 computers and I can able to create a LAN. I have a 2 computers, 2 or more devices, right? So 2 computers are there, so I can create a LAN. Very simple. I have 100 computers, I can create a LAN also. Okay, so 2 computers or 100 computers or 500 computers. It's not about numbers. It is all about a size or a distance. So here it is in a single room. The size of the LAN is can be a single room, or maybe an entire floor one single LAN, or maybe a multiple floors become one single LAN, or entire building up to entire building one. The LAN range is entire building from one single room to entire building, single room or a single floor, or can be a entire building is a LAN, physical geographical range. Geographical range, because originally LAN and WAN is a different concepts, but we are talking in a geographical manner, so compulsory we have to talk in that manner. So LAN. Next one is CAN, campus area network. Next one is a campus area network. What is a campus area network? So within the campus means like you go to university, JNTU Hyderabad is there, Usmania University is there, Andhra University, Visakhapatnam is there, like that. So if you see a university campus or a big colleges nowadays, the colleges also big buildings are there, like a Geetam University or a, KL University is also there. Okay, PAM means advertisement wise, like SRM University. So universities, colleges, big colleges, different departments, simple for understand. Or companies like a TCS campus is there, Tech Mahindra campus is there, Cognizant campus is also there, right? So when you see that one, so there is a main office building and different department buildings are there. If you take the college like a ECE department, EEE department, mechanical department, civil department, your principal office, administrative office is there. So there is a required communication. For example, administrative office want to collect attendance from ECE department, so they can communicate directly. Okay, so they will communicate. Or maybe a civil department want to send a request to the admin department. Okay, so that is they will ask thing. For example, mechanical people require a computers, so they can ask a computer department. So I want a computers availability periods. Okay, so because they are maintaining computer lab, or they need assistance from the computer lab. Or a EEE people require a mechanical assistance, or mechanical people require a EEE lab. Okay, so like that. So it is when they want to communicate each other. Each building is a one LAN network. All combination of the buildings become a one CAN network, campus area network. But the limitation of this network is within the campus only, not outside of the campus. Not a outside of the campus. So that is CAN, campus area network. The next one is, I didn't retain this Metropolitan area network. I think, here it is, some building is there. Metropolitan area network, MAN, M-A-N, Metropolitan area network. So what is this MAN network? It is within the city. In the city, we have a different departments are there. So within the city means in the city also we have a different department. For example, administrative building, like a mayor office is there now. Mayor office is there. Police station is there. Court is there. Hospitals are there. Fire stations are there. Or maybe forest department is there. Road related departments are there, right? They can want to, they require to share the data, they require to share the data, or they want to send information or a bill collection. For example, electricity bill, so you pay electricity bill, electricity supplied by electricity department, and you pay a bill to something like a administrative building, so you are paying a electricity bill. Okay, or maybe there is a case this happened like in a police having some report, so court required that report, so they will get a information from police. Or maybe hospital, some incident is occur, so then hospital people required to send information to police. So it is within the city communication only. The geographical range of the MAN is within the city only. So that is the main point. Next is WAN, wide area network. Wide area network is, so it's a global network. It's an entire global. network. For example, I have our main office, our 70s main office in now. It is in Exton. Okay, it is in Exton. Okay, earlier office is New Jersey. Still New Jersey office is there. So, for example, I have a server in the New Jersey. Okay, I have a main database server something in a New Jersey. Database server is in New Jersey. I have a client PC in my in a Hyderabad. Okay, or maybe application server is running in a Australia. Okay, so like that client, a normal regular client is in a US only. So what happened? We can able to connect all these things together and become a wide network. It is a wide area network. Is simply say it's a global network. Okay, organizations, their departments, can be there anywhere in the world, anywhere in the world. Okay, so the limitation is the globe. The limitation is the globe. So in a LAN, we said the geographical limitation is building. From a single room to entire building is a geographical limitation, and for a campus area network is within the campus geographical limitation. For a metropolitan area network, so it is a limitation is within the city. WAN is it's a global network, it's a public network, so entire globe you can able to communicate. For example, you are we are all using YouTube, right? So YouTube server is in somewhere in this world. We don't know. It is not in Visakhapatnam. It is not in Hyderabad. It is not in Pune. It is not in Delhi. It is not in India. It may not be in India. So I don't know exactly. Okay. So YouTube. Usually the Google servers are mainly located in San Jose, San Francisco, that areas only, right? Okay. Uh, San Jose something is the name is there. Okay, so from there, like there is a lot of replication servers are there. One is at Bangalore, one is at Singapore, like that. Okay, so we don't know where it is, but it is like it is WAN, wide area network. We are nowadays communicating. We are sending a mail, receiving emails, like this through internet, right? So these are all wide area network concept only. Not only office to office, organizations in a different geographical locations, and we are all using internet also. So again, LAN, CAN, MAN, WAN are a different type of networks, and I given a 2 points extra here. So one is a personal area network. So why this is a become notes here? So we'll see. I'm a person. I have a mobile phone which is connected to my smartwatch, right? Smartwatch. Bluetooth earphones are there, right? Bluetooth earphones. Voice assistants like Alexa kind of stuff, Google Assistants built in is there, right? So it is like a personal area network. Smart clothes are there, smart watches are there, mobile phones, smart phones are there, right? This kind of stuff is a personal area network. Whatever it is written, that is we can see like okay. So we can use through Wi-Fi hotspots or Bluetooth connections also. Next, home area network. So home area network means smart homes kind of stuff comes under smart homes kind of stuff. It's like you have a smart TV, small LEDs are there, right? So through Wi-Fi you can able to control your LED through Google Home or Alexa, Echo Dot kind of stuff. You can control your smart LEDs, TVs, or smart plugs are there. Smart plugs are also there. Okay, smart ACs are there. Okay, so home appliances also you can able to control it. It is means in within your home. So you can say like a in a geographical manner because of when you say area network, it is belongs to geographical area. Okay, so home within your home what are the devices we can connect and make it as a smart home. So that is completely like that one only. Like you may control the robotic things are there, like cleaning, robo cleaning, smart cleaning technologies are there. Okay, smart dustbins are there. Smart air pollution kind of stuff is there. Okay, so what's the point here? It is personal area network and home area network. It is we cannot exactly mix with this LAN, CAN, WAN kind of stuff, but still because of the technology changes, we can tell these kind of examples for this. And last time I searched, there's so many ANs are there. Like a BAN is also there, BAN. Okay, so it is maybe I don't know what is the meaning of it. Okay, so different ANs are there, and someone is added this SAN also in that list. Guys, SAN is not belongs to area networks. It is the name is area network because the connection is storage connection is there. That's why people put a area network that time. But it is not a geographical network communication control kind of stuff. Okay. Storage area network belongs to storage solutions. There's a three type of storages are there. One is a DAS. Okay. Direct attached storage. Next one is NAS, network attached storage. Third one is SAN, storage area network. Okay, okay, storage area network. Okay, storage attached network means better option, but it is the name is storage area network. So because of area, so people put this into that this LAN WAN kind of concept. SAN is a storage solution, guys. It is used in enterprises, not for a personal use or not for any other use. It is enterprise solution only in organizations. They can able to offer SAN storage area. It is highly redundant solution. All our data, what we are storing through internet. So all their organization means Google organization, Microsoft organization, yeah, different place we are using, right? So those people are maintaining SAN storages. Okay, it's not for a private or a public access. It is a storage solution. Okay, so again, type of networks are LAN, CAN, MAN, WAN, local area network, campus area network, metropolitan area network, wide area network, and their geographical limitations. LAN is a private network, not a public network, not a multiple networks. Here it is. It's a private network, local area network. Okay, and it is a local network. There is only two main important networks are there out of four. One is LAN, another one is WAN. Okay, because it's a LAN is a pure private network. WAN it is comes to the public network. Wide area network. So CAN is within the campus, MAN is within the city. WAN is a global network. Global network. So it is intercontinent network also. We can say intercontinent or inter-country networks kind of stuff. Means in a geographically from one end to another end we can able to communicate. So global area network. Next to is intranet, internet. So there is another question generally. What is intranet? Intranet means local network. Your LAN is a intranet. So your LAN is a intranet. So look at here, guys. This is a server is there. For example, it is a some kind of web server I am maintaining in my LAN. It is connected to my LAN switch. Okay, PCs are connected. PCs are connected like this. I am communicating to this switch, to this web server. Or I am communicating from here to here. For example, this is APC, BPC, C, D. This is S1. So C to S1 communication. Within a local only. I am not using any internet here. No other connection, no ISP, nothing. No external connection. So I am communicating within the my LAN connection only. So that is called a intranet. That is called a intranet. What is internet? Global network. For example, I have a Gmail server somewhere in the globe. We don't know where it is located directly. I want to communicate from this PC to here. How to communicate? First of all, packet sent to your switch, then your router, and router to modem, or a mixed kind of stuff, ISP, Internet Service Provider, and it is finally from there to other places, like it is like a traveling kind of stuff only. Okay, this is up to our home. Okay, this is our LAN. This is our WAN connectivity. This is our WAN connectivity from ISP to outside. Finally, we reach the server. Meaning is, what is a WAN, wide area network? Means when you are trying to step out from your local network to communicate within the WAN, communicate outside of your network, we have to connect through WAN only. So that is why WAN is also an example of internet connection. Again, guys, intranet means LAN, local, it's a private network. Okay, we don't require any internet service providers, WAN connectivity or anything. We don't require this within the organization, within that room only. Okay, it's a private network. Internet, for example, I'm accessing I'm accessing some website, Microsoft.com, or I'm accessing a YouTube. Okay, so somewhere it is located, these servers, it's not in my room, it's not in my local network. So compulsory I have to go through internet only. So then I can able to reach this server, right? So that is internet. It is a global. Okay, it is networks of network. It is a networks of network. So globally connected network. Public network. Internet is a public network. Intranet is a private. I can access my server because it's in my room. You can't access my server because you are in a different network. You and me both, we can able to access YouTube or a Gmail or a Yahoo Mail or a Microsoft.com. Why? Because those who are in a public. Okay. So that's the point I'm trying to tell. Okay, guys, understand? So LAN, MAN, WAN, intranet, internet.
Yes, sir.
Very good. Next thing is, what is a basic LAN topology? It is, you can see there is some connecting device, networking hub, and workstation means normal desktops, and there is a server. So that's it. Okay, means they required a connection box for a hub or a switch kind of stuff, and there is connections. That's it. So wireless concept is there. So once you are connected, basic LAN will be created. Okay, of course, this is the WAN kind of stuff. Okay, this is a type of networks, and here it is basic requirements of a network. So we'll go to that point again. That is very important. But I'm jumping out. Okay, I'm jumping from there. I'm not. Yeah, very good. So here it is. I want to go to topologies because it's very easy to cover topologies, which we already know. Guys, there is a basic topologies are there. Topology, there are two types. One is a physical topology, another one is a logical topology. If an interviewer asking a question, what are the topologies? What are the topologies? Don't ask him, sir, are you asking about a physical topology or logical topology? Don't ask like that. Okay. Okay, so that's very important. So important is when you ask a topology means it's a physical topologies only, or if you ask a physical topology, it's definitely physical topologies. What is these physical topologies? The way you connect the devices. I already said network, not networking. In a network, two or more devices are connected. It is called a network. So to create a network, how you connect? How you connect? So that is called a topologies. Okay. Here it is. I have put other means also. So yeah, we can easily cover. So normally I use paintbrush to show you all these things. But now it is also good. Guys, you have taken a PC and there is another PC and you connect it direct wire. So like a device is connected to another device is called a point-to-point connection. Point-to-point. Okay, so remember that point. Next, so important topologies are bus topology, important topologies are bus topology, ring topology, mesh topology, and star topologies. So first of all, we'll discuss those kind of stuff here. So bus topology is basically there is a backbone wire. So you can look at this is the backbone wire. Okay, devices are connected to backbone wire. Usually those days they use a coaxial cable. Coaxial cable. Maybe you remember, may not be. Okay, so now we have a dish TVs. Earlier we have a cable TVs. Cable network, like there is a cable antenna maintenance person is there in the village. So in the village or towns, what they will do, so they run the cable from their station to the streets and from streets to houses. So there is a one single main wire is there, from that wire to all other TVs are connected. Okay, so you're using a coaxial cable. Still, we are using a coaxial cable, but not this kind of cable network. We are using a dish network. So digital based network it is. Okay. So here it is that time computers, either they, it is very difficult to connect point to point wise because very limited connections. So so don't forget about it. It is a very easy to configure because you need a very big single backbone wire and simple you can connect devices to backbone wire. But there is a problem. If in case this backbone wire is broken, the communication will stop. Okay, there is a communication between example AC to C or A to D or B to C or B to D communication will be stopped. So what is the disadvantage of that one? So it is very easy to configure and it is cheaper solution. Okay, but the problem is it's difficult to troubleshoot because of nowadays we are not getting these kind of problem. Earlier we got this problem because the cables, power cables in a home, somewhere it is broken within the wall, so you can't find where it is broken. It is very difficult, so you have to use some meters and all, and you have to break set place in the walls. Okay, so again big tracing is there. So not quick and easy kind of troubleshooting is not there, but it is very easy to configure and cheaper solution because you don't record anything, simply a backbone wire and you have to connect to the backend wire. So next one is ring topology. What is the ring topology? In this one, every PC is connected to another PC. Every PC, like A is connected to B, B is connected to C, C is connected to D, D is connected to E, and E is connected to A again. Means Once you reach the last device is connected to the first device. And this ring topology, these devices are communicated based on the algorithm. Okay, how it is? For example, I want to communicate from A to D. Okay, so there is a already pre-written algorithm is there. You want to communicate from A to D. So A is connected to B. So first send a packet to B, then B to C, and C to D. Okay, see it is 1, 2, 3 devices. It should be crossed. For example, C to D is disconnected. You can't communicate it to D. You know the funniest thing, D can communicate it to E through E. Sorry, D is communicating, D send a packet to E, E to A, we can send it. But A to D communication is not there. Okay, but it is also a very good protocol. Okay, of course, compared to bus topology. So we have somewhere communication is there. So communication not completely stopped, but there is a communication between the devices. Okay, but problem is more devices increases. You have to configure each and every device. You have to tell how to communicate. How to communicate. Okay. Next, if ring is broken or a device is failed, communication is stopped because it communicates either clockwise or anti-clockwise only. So to solution to that one, so people are use this technique. For example, this is a clockwise. I'm putting a anti-clockwise algorithm and a connection. Of course, connection and algorithm both are there. Connection is important, algorithm is also important. Okay, so if in case this wire is broken or a device is down, no problem, still we can able to communicate. So ring topology issue is solved by double ring topology. So you put a two rings, so it is become a double ring. Okay, so ring topology means every device is connected to the next device, the last device is connected to the first device. Okay, and one more challenge is there. If you are adding a device, it is again you have to change the algorithm. So that's the point in the ring topology. Those are the difficulties, advantages and disadvantages of ring topology. I'm not giving any notes, guys. Remember each thing. Bus topology, backbone wire is devices are connected to a single backbone wire. Ring topology, every device is connected to other device. And finally, the last device is connected to first device. So this is a ring topology. It uses an algorithm to communicate from one device to another device. The next one is important, mesh topology. It is a mesh topology, guys. Some people see here and they think it is a they think it is a star topology. It is not a star topology. It is a mesh topology. Okay. In the mesh topology, each device is connected to all other devices, not only a next device, for every device. A is connected to B, C, D, E. E is connected to all other devices like A, B, C, D. D is connected to A, B, C, E. Okay, like each device is connected to all other devices. It is a highly redundant device. So highly redundant network configuration means if a wire is broken, no problem. Still there is a communication with the different parts. Okay. Another hand, only that part of communication will stop, but remaining communication is going on. For example, a device is dead, a device is down, no problem. We'll communicate with all other devices, so we don't depend upon any one. Okay. Like the ring topology, a C is down. Big problem. So A to B communication is there. B to D communication will stop because C is down. Alright, wire is broken. Further communication will be stopped. But in a mesh topology, it's not like that. It's not depends upon any centralized device or a individual devices. Every device is connected to all other devices. So obviously it will going to communicate. Next. Guys, understand up to here 3 topologies I have told. One is bus topology, ring topology, mesh topology. The final one is not final, a very important topology which we are using nowadays is a star topology. What is star topology? There is a centralized device. There is a centralized device. All the devices are connected to this central device only. The central device is nothing but either it is hub or a switch. We use it to connect the devices. Okay, so forget about the second part. So look at this part only. Okay, a simple a segment or a LAN connection. So you can see A is communicating to B. How it will communicate? Look at here. A send a packet to this hub or a switch. From hub or a switch to B will send. Okay, it is very easy to configure. Little cost. Why little cost? 1 second. What is this? It is a little cost. Why? Because of we are using a separate device, hub or a switch we are using. So little cost is there. Centrally connected. So every device is communicating through this central device only. For example, E want to send a message to G. E want to send a message to G. How it is sent? E to this hub up to G1. So these are the points I'm talking. Okay. Okay. So these are the points I'm talking about. So here it is. Look at here. This star topology is simple devices connected to a centralized device, either it is hub or a switch. So these devices will communicate each other through this hub and switch only. It is not much reliable as a mesh topology. Why? Because of in a mesh topology, each device is connected to all other devices. In a mesh topology, it is a reliable because of any wire is disconnected or maybe a device is down, all other devices will communicate each other. Okay, only the down point won't work, but remaining is going on. So no problem with that one. It not affect on others. So that's why it is a reliable. And mesh topology is only used in a high redundancy area requirement. For example, I showed a SAN, right? A storage area network. So in the storage solutions, they use this kind of stuff. In the server to server routers, main important means like a ISP provider, core routing or networking solutions. People use mesh topologies, not for a regular communications. Okay, because mesh topology not only just a reliable network, but there is a lot of problems are there. In mesh topology is a complex. Mesh topology is a very complex to configure because of a new device is added. Think like this. There is a 5 computers. New computer is added, for example. Again, I have to connect from each device like this. It's very difficult to scale. Scale means increase the topology size. Increase the size. We can't scale. Okay, it's very difficult to scale it. It's very complex, and it is very complex to troubleshoot. When wire is down, so where is that wire? Where to where it is connected? Like this one. Okay, so little bit difficult, but it is highly redundant. But still, it's a complex and difficult to scale. On the other hand, star topology, it is very easy to configure, little less reliability or no reliability at all. Why? Because of if centralized device is down, entire communication is stopped. You know, when we are in even myself, when we are in a childhood days, you are not allowed to say negative questions like what if this server won't work, what if this cycle won't work, what if my bike won't work, okay, my bike will stop. Like this negative questions you should not say, because if you say negative, these things will be happens, definitely negative only. But in our infrastructure management, negativeness is first important. Why? Because of the positive thinking is a completely backwards concept. It's positive thing is it's different ways. It is positive thinking in a positive manner. That's the different point. Negative thinking does not mean you should not use a question or a word in a negative way. Okay, it depends upon the situations. You have to put that kind of stuff. For example, what happens if the centralized device hub or a switch is down? What happens if this hub or a switch is down? What happens, guys? The entire network collapse. Is it a possible? Yes, possible, right? It is also electronic device. You have a mobile phone in your hand. There's a possibility of your mobile phone can be damaged, something down, some battery or some application issue, or maybe some processing issue, right? Issue can be there, right? Maybe now or later. What is a immediate solution? You have to find it, right? Either you are using another secondary mobile phone is there, or using any feature phones for temporarily, like this. So some secondary plan or no plan. Okay, so like that. If server is there, there is a server. You have to think always positively. If you think positively, positive things will happen, right? So server is there, web server or Google server is there, Google search engine server is there. Okay, Gmail server is there, YouTube server is there. So YouTube guy thought like a Google guy thinks. Okay, so we think very always a positive. This server will runs forever. Okay, due to the load on a server, load increases, server down, right? Automatically, so server is down. How many crores of loss they will get it for just if it is down for half an hour? Think about it. Lot of crores of billions of money they will lose. Services, customers, right? So what they will do? They will always put a question that is called a risk management. Risk management. What if this server is down? So then what they will do? They will put a backup servers. Okay, there is a 10 servers are there, works parallelly. 10 servers works parallelly because it's a high risk. Okay, 10 servers or 20 servers or 30 servers run parallelly. Different geographical areas they deploy these servers. Different geographical area, maybe some geographical places, some damage may occur, like earthquakes will occur, maybe tsunamis may occur, or maybe wars may be declared, right? So like now Ukraine war is going on, right? Like lot of places, lot of things are there. Floods will have happens. Okay, so geographical way also it maybe there is a cause of problem. So they deploy these servers into different geographical location. Important is data. So data means information. Make sure people should be able to access their data or information or a service, right? So that's a point I added here. Do not think I'm deviated, guys. Simply it is, I'm understand. Always there is a reliability question will be important. That is called a risk management. In ITL, there is one of the point is risk management. Without planning that kind of stuff, your infrastructure will be in a danger. If your infrastructure got in a danger, your company is already in danger. Already in a danger. So few things you have to take. So that's again we'll discuss. If you will try. Okay. Yeah, here it is. This is hub array switch. Devices are connected to hub array switch. So then it is a star topology. So each device is communicating to other device through this hub array switch centralized device. If centralized device is down, all communication is down. And we'll talk in another manner. So one is if a PC is disconnected, so only one PC is not communicating. All other PCs are able to communicate. Unlike your bus topology and ring topology, if a PC is down, okay, if a PC is down or it is disconnected, no problem, all other devices will communicate each other. All other devices will communicate each other. But if my switch or a hub is down, entire communication will stop. So that's why it is non-reliable as compared to mesh topology. Mesh topology highly redundant and reliable network. Star topology, no redundancy, not reliable, but easy to configure, very easy to troubleshoot. Very easy to troubleshoot. One device is not connecting, all are communicating. We can understand only one device problem, either it is a cable problem or a system problem or a port problem. There is 10 computers are connected. All 10 computers are not able to communicate. They are disconnected. All 10 computers disconnected. Where is the problem? Centralized device problem. All are connected to one device only. All are disconnected. Meaning is it's a centralized one problem. So like that, we can easily understand where the problem is occur. So then we can easily troubleshoot it. So that's the importance of this star topology. So I have taken a lot of time on it. Again, guys, what are the different topologies? Bus topology, ring topology, mesh topology, star topology. Other than this, there is a few more topologies are there. Example, point-to-point topologies, hybrid topologies, point-to multi-point topologies are there. Point-to-point topology means a device is connected to another device or a similar or dissimilar device. Like a PC is connected to hub or a switch. A PC is connected to another PC directly. Okay, a PC is directly connected to hub, or the hub or a switch is directly connected to a router. So that is called a point-to-point. Next, point to multi-point. A device is connected to multiple devices. For example, a switch is connected to multiple computers. A router is connected to multiple routers. Okay, so like that, that is called a point to multi-point topologies. And one more is there, that is called a hybrid topologies. When there is a mixture of two or more topologies together, become a hybrid topology. For example, here it is a star topology. This is a star topology. All devices are connected to centralized device. Now, each PC is also connected to all other PCs like this. Sorry. For example, like a mesh, each PC is connected to all other PCs. Like a mesh. So this is called a full mesh topology. Mesh topology plus star topology called as a full mesh topology. Okay, it's a hybrid topology. And each topology, if you see, everything is point to point connected plus another topology kind of stuff. It is obviously thing. And there is a two star topologies. If you look at, this is a one topology, this is another topology, right? Two star topologies, and these switches are connected to another one. It is called a extended star topology. This is called a extended star topology because of star topology easy to scalable, easy to configure, easy to troubleshoot, easy to scalable. We can scale the topologies kind of stuff. So these are the main topologies, guys. Bus topology, ring topology, mesh topologies, star topology. These four are very important topologies. And there is a additional topology is called a hybrid topology. Bus, ring, mesh, star, hybrid, extended star, full mesh topologies are there. Next, we can say point to point and point to multi-point star. From last 2 years, people are asking only one question, that is called they leave everything aside. They are asking tree topology. Sir, what is tree topology? Because there is nothing called as tree topology. This is also someone is made it and added to here into the tree topologies. But because of people are asking a tree topology, I'm telling like this. This is it's a tree type structure, hierarchical structure it is. Like there is a core server and it is connected to multiple like a core router is there, or a switch is connected to multiple switches or routers like a distribution layer, and there is a access layer. So one device is connected to some devices, and some devices, those each individual connected to multiple devices. It is like a hierarchical structure it is created. So this is also called as a tree topology. Why I have written separately? Because it's not there earlier. Someone is created because of the tree topology. This is also a tree topology. Extended star topology is also, we can say, a tree topologies. Okay. Extended star is very important in any organization. We are all using connections. Okay. Yeah, that is enough. So people are already getting a headache. So these are the explanation of a bus topology, ring topology, mesh topology, star topologies. So last batch I stopped at here, I think so, and I didn't add some more information should be added. So last part I added like this: small office, home office kind of stuff. Small office, home office kind of stuff. It is like here is a switch. Devices are connected to the switch. It's a simple LAN network. Okay, when I want to communicate outside of my network, I need a router. I need a router. The router is connect two or more networks. Two or more networks together means internetwork device. Internetworking device. What is internetwork? Connection of two or more networks. Internetworking. Two or communication between two or more networks. Two or more different networks, right? Internetworking. So router is an internetworking device. Means you have your own private LAN network and you want to communicate outside of your LAN network. So you want to communicate different network. So we need a router. When you want to communicate different network, you need a router. Okay. You want to communicate through internet, we need a modem. You want to communicate through internet, you need that kind of connection, you need a modem. Okay, so modem connects your network to internet through ISP provider. So modem actually make a connection to ISP provider, internet service provider. Okay, so I want to communicate to google.com. So from my PCA to google.com, PCA send a packet to switch, through switch to router, router to modem, modem to ISP provider. So ISP taking your packet and sent to the google.com through the network. So there is a lot of connection. One connection is one to another one, one to one, one to one, like a lot of connections are there. they'll connect each other. So that is like that. Okay. I don't know people understand or not. So again, this is, yeah, here it is, tree topology. Why tree topology came up? Yeah. So small office thing. Okay, guys, you have your network, like I have a laptop, desktop, mobile phone, tablet is there. So that is in my LAN network, which is connected to my router. The router is both things are there, routing and modem connection is there. So router make a connection, communication between my local LAN network to outside of my network. Okay, so that is a thing. I will explain this thing again if possible. There is a default gateway. What is a default gateway? Also written here. Not written means it is showed here. From my laptop to my router, I have to pass. Okay, so this is a thing. I will explain it again. Okay, so every point is very important here. So I will come back when I am discussing about a devices, networking devices. Yeah. So what I will do, just take a 5 minutes break, guys. Just the 5 minutes is enough. I'll take it only 15-20 minutes class only. But this time I will tell how to check the MAC address, how to check the IP address, and what is trace RT, what is a trace RT kind of stuff. Basic commands I will tell. Okay, basic 4-5 commands are there. Only commands I will tell. Okay, so tomorrow we'll start a little early. We'll try. Otherwise, we'll see. We'll discuss about different devices, cables, NIC is also there. So okay, no problem. I'll start with what is NIC. Okay, I will start with what is NIC. Then IP addresses also I will tell. So IP addresses, MAC address. Okay, how it is look like, how to get some ping command, kind of stuff. Okay, take a 5 minutes break, guys. 1:14 it is. 1:15. Okay, by 1:15 we'll be back.